Jack Jackson. In this video we're going to be deriving start deriving our derivative rules, and these rules are shortcuts to using the definition of the derivative to compute derivatives. And the easiest of those is to look at constant functions. So I'm going to start with the GeoGebra app here. This is my calculus book, Calculus Collected Resources, is a GeoGebra book you can find on GeoGebra's site. And I'm going to go to Unit 4 here, and we see several different things here. Most of these I've written, and some others have been written by other math educators. So I'm going to do derivative of a constant function and look at this first. Okay, so we're going to start with this particular app. So notice that a constant function is just a graph of a horizontal line. Okay, and the horizontal line looks like this. Y equals a constant, so for example y equals 3.8. It's just a horizontal line. Now what's the derivative going to look like? Well, it's pretty easy to see that the derivative is just going to be 0. Now why is that? If you take any 2 points on this original line, the blue one here, the constant function, and you look at the secant line, that is the line between those 2 points, it's the same line that we started with. And therefore when you take a limit of those, the tangent line in this case at any point is the same as the original line. So the slope of all those difference quotients, all those secant lines is the difference quotient, and the slope of all those tangent lines is the derivative, and all of them are just the slope of that original line. Well, that original line is a horizontal line, and as you know, a horizontal line does have a slope. It is 0. Don't confuse that with the line which does not have a slope or has no slope, which is a vertical line. But if we have a constant function, the derivative is going to be 0 everywhere. When we graph the function of y equals 0 everywhere, that's just the x-axis down here. Now, if we want to prove that, we can click on this proof thing, and we can see the proof written out here. I've got it a little bit bigger here. I'll bring this up here. So here is the algebraic proof. Remember, f prime of x is the limit as h goes to 0 of f of x plus h minus f of x over h. That's the definition of the derivative. But for this function, f of x equals c for some constant c. For example, up here it's 1.5. Doesn't matter, any c value. Then f of x is c. But f of x plus h is also c. c minus c is 0, and 0 divided by any non-zero h is 0. Remember, h is not 0. It's only approaching 0 in the limit. So 0 divided by h is 0, and you take a whole bunch of zeros and you take the limit of that as h goes to 0, that's still just 0. So in fact, that proves that. So the way you apply that in a real-world problem is, say the derivative of 7 is 0. What about the derivative of pi? That's 0. What about the derivative of e to the 7 pi? Well, all that's still just a constant, so the derivative is 0. Super easy rule, but it's certainly the one we can start with. The derivative of a constant is 0. That's our conclusion. The derivative of a constant is 0.